Ohm's law is a fundamental principle in electrical circuits, and it describes the relationship between voltage, current, and resistance. The formula for Ohm's law is I equals volts divided by resistance, where I represents the current in amperes, volts is the voltage in volts, and resistance is the resistance in ohms. To determine the current in a circuit, you can use this formula if you know the voltage and resistance. Let's consider a circuit consisting of a 1000 ohm resistor with a voltage of 50 volts across it. To find the current, we will apply Ohm's law. Using the formula I equals volts divided by resistance, we substitute the given values. In this case, the voltage is 50 volts, and the resistance is 1000 ohms. So, I equals 50 volts divided by 1000 ohms. Performing the division, we find that I equals 0.5 amps. However, the answer choices are given in milliamperes, so we need to convert amps to milliamperes. To convert amps to milliamperes, we multiply the value in amps by 1000, since there are 1000 milliamperes in 1 amp. Therefore, 0.5 amps multiplied by 1000 milliamperes per amp equals 50 milliamperes. Thus, the current in this circuit is 50 milliamperes. So in summary, the following steps were taken. Firstly, we identified the known values, which were the voltage of 50 volts and the resistance of 1000 ohms. Secondly, we applied Ohm's law, which states that current equals voltage divided by resistance. Thirdly, we substituted the known values into the formula, resulting in current equals 50 volts divided by 1000 ohms, which equals 0.5 amps. Fourthly, we converted the current from amps to milliamperes by multiplying 0.5 amps by 1000, resulting in 50 milliamperes. Therefore, the current in this circuit is 50 milliamperes. Now let's delve a little deeper into the concepts of voltage, current, and resistance. Voltage, often described as electrical potential difference or electromotive force, is the driving force that pushes electrons through a conductive material. It is measured in volts, and is the amount of potential energy available to move charge from one point to another in a circuit. A higher voltage implies a greater capacity to drive current through a circuit. Current, on the other hand, is the rate at which electric charge flows through a circuit. It is measured in amperes, which represents the amount of charge passing a given point per unit of time. 1 ampere is defined as 1 coulomb of charge flowing per second. The flow of current is influenced by both voltage and resistance. Resistance is the opposition to the flow of electric current in a circuit. It is measured in ohms and is analogous to friction in a mechanical system. A higher resistance restricts the flow of current for a given voltage. Materials with high resistance are called insulators, while materials with low resistance are called conductors. Ohm's law provides a quantitative relationship between these three fundamental electrical quantities. It states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points and inversely proportional to the resistance between them. Mathematically, this relationship is expressed as volts equals I times R, where volts is the voltage across the conductor, I is the current flowing through the conductor, and R is the resistance of the conductor. Ohm's law can be rearranged to solve for any of the three variables if the other two are known. For example, if you know the voltage and resistance, you can calculate the current using I equals volts divided by R. Similarly, if you know the current and resistance, you can find the voltage using volts equals I times R. And if you know the voltage and current, you can determine the resistance using R equals volts divided by I. Ohm's law is a versatile tool that can be applied to analyze and design a wide range of electrical circuits. It is used in everything from simple circuits with resistors and batteries to complex electronic systems with transistors and integrated circuits. Understanding Ohm's law is essential for anyone working with electricity or electronics. Furthermore, it is important to understand the units of measurement used in electrical circuits. Voltage is measured in volts, which is the potential difference required to drive 1 ampere of current through 1 ohm of resistance. Current is measured in amperes, which is the rate of flow of electric charge equal to 1 coulomb per second. Resistance is measured in ohms, which is the opposition to current flow that results in a voltage drop of 1 volt for every ampere of current. These units are part of the International System of Units, also known as units, and are universally used in science and engineering. When working with electrical circuits, it is also important to be aware of safety precautions. Electricity can be dangerous, and it is essential to take steps to protect yourself from electric shock. Some basic safety tips include always working with de-energized circuits whenever possible, using insulated tools, wearing appropriate personal protective equipment, and following all applicable electrical codes and standards. In addition to Ohm's law, there are other important concepts in electrical circuit analysis. These include Kirchhoff's laws, which describe the conservation of charge and energy in circuits, as well as techniques for analyzing series and parallel circuits. Kirchhoff's current law, also known as the junction rule, states that the sum of currents entering a junction in a circuit must equal the sum of currents leaving the junction. This law is based on the principle of conservation of charge, which states that electric charge cannot be created or destroyed. Kirchhoff's voltage law, also known as the loop rule, states that the sum of the voltage drops around any closed loop in a circuit must equal 0. This law is based on the principle of conservation of energy, which states that the total energy in a closed system remains constant. Series circuits are circuits in which components are connected end to end, forming a single path for current flow. In a series circuit, the current is the same through all components, while the voltage is divided among the components according to their resistance. The total resistance of a series circuit is equal to the sum of the individual resistances. Parallel circuits are circuits in which components are connected side by side, providing multiple paths for current flow. In a parallel circuit, the voltage is the same across all components, while the current is divided among the components according to their resistance. The reciprocal of the total resistance of a parallel circuit is equal to the sum of the reciprocals of the individual resistances. By understanding these fundamental concepts and applying them to specific circuit configurations, you can analyze and design a wide variety of electrical systems. Now let us revisit the example we initially discussed, focusing on the conversion between amperes and milliamperes. We determined that the current in the circuit was 0.5 amps. To express this current in milliamperes, we multiplied by 1000, obtaining 50 milliamperes. This conversion is necessary because milliamperes are a more convenient unit for expressing small currents, which are commonly encountered in electronic circuits. For instance, currents in integrated circuits, sensors, and communication devices are often in the milliampere range. It is important to be comfortable converting between amperes and milliamperes, as well as other related units such as microamperes and kiloamperes, to effectively work with electrical circuits. Understanding the relationship between voltage, current, and resistance, as described by Ohm's law, is also critical for troubleshooting electrical problems. For example, if you measure a voltage across a resistor but there is no current flowing, it could indicate that the resistor is open or that there is a break in the circuit. Conversely, if you measure a high current through a resistor with a low voltage drop, it could indicate that the resistor is shorted or that there is a low resistance path in the circuit. By using Ohm's law and a multimeter, you can diagnose many common electrical faults. Furthermore, Ohm's law is essential for calculating power in electrical circuits. Power is the rate at which energy is transferred or consumed in a circuit, and it is measured in watts. The power dissipated by a resistor is equal to the product of the voltage across the resistor and the current flowing through it. Mathematically, this is expressed as power equals volts times I. Using Ohm's law, we can rewrite this equation in terms of resistance as power equals I squared times R, or power equals volt squared divided by R. These equations are useful for determining the power rating of resistors and for calculating the energy consumption of electrical devices. In summary, Ohm's law is a cornerstone of electrical engineering and a fundamental tool for understanding and analyzing electrical circuits. By mastering Ohm's law and related concepts, you can gain a solid foundation for further study in electronics and electrical engineering. Remember to always prioritize safety when working with electricity and to follow all applicable codes and standards. Now let's talk about real-world applications. Ohm's law isn't just a theoretical concept. It's used every day in countless applications. Firstly, consider the design of electrical circuits in electronic devices. Engineers use Ohm's law to determine the appropriate resistor values to ensure that components receive the correct voltage and current. Secondly, Ohm's law helps in troubleshooting electrical problems. Electricians use Ohm's law to diagnose faults in circuits by measuring voltage, current, and resistance. Thirdly, Ohm's law is also used to calculate power consumption. Knowing the voltage and current allows you to determine the power used by a device. This is essential for energy efficiency and cost management. Fourthly, in audio systems, Ohm's law is used to match impedance between amplifiers and speakers. This ensures maximum power transfer and prevents damage to the equipment. Fifthly, Ohm's law plays a role in renewable energy systems. It helps in calculating the current and voltage generated by solar panels or wind turbines. Sixthly, in automotive electronics, Ohm's law is used in the design of various circuits, including lighting, ignition, and control systems. Seventhly, understanding Ohm's law is crucial in telecommunications for designing and maintaining communication networks. Eighthly, medical devices rely on Ohm's law for accurate and safe operation. Ninthly, in industrial automation, Ohm's law is used in the design and control of motors, sensors, and other equipment. Tenthly, educational institutions use Ohm's law to teach students the fundamentals of electrical engineering and electronics. As a final example, let's consider a simple LED circuit. Suppose you want to connect an LED to a 5 volts power supply. LED have a specific forward voltage drop, typically around 2 volts, and a maximum forward current, typically around 20 milliamperes. To protect the LED from burning out, you need to use a resistor in series with the LED to limit the current. To calculate the required resistance, you can use Ohm's law. The voltage across the resistor will be the difference between the supply voltage and the LED forward voltage, which is 5 volts minus 2 volts equals 3 volts. The current through the resistor should be equal to the LED maximum forward current, which is 20 milliamperes or 0.2 amps. Using Ohm's law, resistance equals volts divided by I. We get resistance equals 3 volts divided by 0.2 amps equals 150 ohms. Therefore, you should use a 150 ohms resistor in series with the LED to limit the current to 20 milliamperes. This example demonstrates how Ohm's law can be used to design a simple but practical circuit. This is just one example of how Ohm's law is used in real-world applications. It is a fundamental principle that is essential for anyone working with electricity or electronics. Understanding Ohm's law will enable you to analyze, design, and troubleshoot electrical circuits effectively.